Well, thanks everyone. What I'm going to do is briefly walk through some of the different new things in the HPC market. In particular, I was asked to look at some customer pain points, in particular with the light of where a new business opportunity would make the most sense to address. For those of you who don't know IDC, we try to track everything sold in the industry every quarter. We've been doing it for 45 years, and the HPC realm is a company a little longer than that. We also hold 4 user forum meetings a year, and we invite new startups and people with new ideas to come to our user forums. In particular, if you're interested in partnerships, because we bring government, industry, and academia together. So if you're interested in that, just let me know, and we're glad to have you present there. No charge for presenting or attending for startups. We also do have to publish a lot of reports on that. In addition to HPC, we are now also tracking cybersecurity. And there's some tremendous startup potentials and availabilities in cybersecurity right now. As you can see with what the US election just went through in the last year, the market for cybersecurity and new solutions is just skyrocketing to a new level. So first of all, Steve Conway and my team put this together. Why is HPC a hot market for startups from our viewpoint? Well, if you kind of have a longer range view, in 1990 the market was around $2 billion. Right now, if you count the servers, storage, and just repair services, it's grown to over $20 billion. So there's been some tremendous growth here. We also expect to continue to see robust growth, somewhere in the 6%, 7%, 8% for the traditional HPC segments. But the other big part of the market that it really is growing is when you take high performance computing and big data together, it's creating all kinds of new solutions, and that's growing at greater than 20% a year right now. So just some phenomenal growth there. It's also playing a key role in a lot of formative markets for machine learning, AI, self-driving cars, Internet of Things, and that. There's all these little segments, and each one of them need point solutions in addition to what I call the grand solutions. And those point solutions are where startups can step in fairly quickly. Shaheen, I think you mentioned a few different funding sources also in that, and one thing I want to suggest is don't be shy of just going for straight government grants, because right now the government grant, like the Department of Energy, Department of Defense, they actually don't spend all the money they have. And some of the requirements there is simply you have to publish some part of the research results. And that doesn't have to be your core IP at all. You just have to publish some research results. They can be anywhere from, the typical grants are about 3 years long. And like I said, even though there's a pipeline, they don't say yes to everyone, they never spend all their money. So they're actually hunting for people to submit to those grants. And for a government department, they either spend the money this year or they lose it. So it's something that they really would like to do. So with that, I'll give you a brief market update. 2016 is looking good, as I mentioned, around 6–7% growth. The very high end of this market has slowed down. The top 5 machines in the world, we're in a slow period, but that's very much a roller coaster type market. If you ignore the top 3 to 5 machines, the market's actually growing closer to 10% a year right now. Tremendous things about exascale. One thing we suggest for anyone who's doing something in HPC, whether it's software, storage, hardware, services, get the word exascale somewhere in there. I mean, because right now, everyone wants to chase exascale. It's the new World War kind of race as far as the arms race. And it used to be each country wanted the largest supercomputer. Now it's very different. Each country wants a whole suite of supercomputers in every functional area. So everything in exascale is kind of like a significant guidepost that everyone's pointing to. I mentioned earlier the big data portion on that. And so here's a picture of what the overall market's done. As I mentioned, you can see from 2009 there's been some reasonable growth here. And again, if you take off the top 2 or 3 largest machines, the growth is actually quite a bit higher, because that's what's causing that roller coaster effect. And here's it by the different industries. So if you're thinking of startups, the bio life sciences, is a very strong portion of the market, on the order of about 10%. But the bio life science has what we call the tipping parts of the market. Things like precision medicine, things like genomic processing. There's things where they're just escalating. And again, once certain things happen, those markets could be larger than this whole market going on. For example, healthcare reform. The amount of money that's going into just improving healthcare. And I'm not talking about Obamacare. I'm talking about the fundamentals within healthcare, how services are delivered, how it's measured, how it's improved. How do you go through all the myriad of data and come up with better solutions? The amount of money that's flowing there is just tremendous. And these are giant experiments. Places like big insurance companies and MIT are pulling together hundreds of millions of dollars. And they're bringing in about 25 different startups, because they want the startups to help them in very specific areas there. But this kind of gives you a whole realm, and I think the slides can be made available to everyone. Yeah, so I won't. Just again, a perspective, just how the market looks as far as the different vendors. HPE has become the market leader by a long shot. It used to be HP and IBM were in competition for leadership, but IBM sold off a lion's share of the business, all the x86 business, to Lenovo. And quite frankly, in the last 18 months, when IBM sold that x86 business to Lenovo, and then to now, half of it's gone. Actually, 65% of that business has gone to other vendors. And that's why you see the combination of IBM and Lenovo is a dramatically smaller segment than it used to be. One thing we've changed in our reporting, I mentioned this high-end problem, with the top 3 or 4 systems. We actually have changed thing. Normally this is market data, so we never show an individual customer sale. But we've decided at the very high end of the market we're going to change those rules, and that's why I've got the arrow there. That's the one new machine that went in China. So from now on, these giant machines we're going to show as if it's a separate system. That way, you can remove all those fewer machines that are causing this wave function and see what the real fundamental market is. And we split up the market in these 3 broad categories. Supercomputers are $500,000 and above, divisional, departmental work group. You can see here that there's some real significant differences in the growth. Part of the reason supercomputers are growing heavily right now is 2015 was somewhat of a low year for that roller coaster effect. But don't take your eye off the lower end of the market. In particular, the people in the work group, so that's less than $100,000 servers, they're a different buying population. One, they're not going to go out and write their own software. They may use software that somebody in their company wrote 20 years ago, but they're not writing new software. 2, they're not computer scientists. They want these machines to do a job for them. So in addition to the hardware, softwares, and all that, the whole service business in there is a massive opportunity right now to literally go in and just help them set up the system, show them how to use it, and get them started. And if you have any form of vertical expertise, they welcome you on right now. And here's the broader market if you want to look at server, storage, middleware, applications. And the service here is just the repair services. And here we're projecting the market will actually hit $31 billion by 2019. So it's just tremendous growth there. Let's see. Oh, I guess I'm doing okay on time. So some of the top trends that we're looking at right now where there's opportunities again to help the market. There's a whole new set of processors that have been hitting the market, whether it's from Intel, NVIDIA, ARM, Open Power, new versions of RISC. And right now these customers don't know how to use those. And the particular question on most of the sites that we talk to, and we do lots of surveys. Last year we did about 15,000 separate surveys of buyers. They have no idea where these different products fit. And so one of their biggest questions is profiling and then helping them figure out how to make use of them. New types of interconnects. There's a lot of debate right now, for example, on storage. Will the machines of the future be 100% flash-based storage, or SSDs, versus disk? I noticed Gary spoke earlier today. I'm sure he mentioned some of their experiments they're running at Los Alamos. Tremendous opportunities there, but in particular, the whole set of this chart that I'm showing here with the new technologies fundamentally means that almost all software has to be rewritten in this sector. So all applications right now, in general, need to be redesigned. They were all designed to work on one processor originally. When I mentioned most of these apps are like 10, 15 years old, they were designed to work on one processor. Right now, these machines, the processors are basically free. The amount you get. That number 1 machine I showed that was $300 million, 10 million cores, processor cores in there. So you're talking about a different realm of scaling. Most industrial codes right now scale to 4 processors to 8 processors. Represents the bulk of the market. So they need to be revamped and rewritten to scale to something like thousands or tens of thousands. And from our surveys, that's the top area that people are willing to pay for services right now, to help them rewrite their software, redesign it. And here are some of the different things that people are trying. Another key area is the whole issue of cloud computing. Right now in HPC, most HPC jobs don't work well in a cloud. They have to be redesigned to work in a virtualized environment. And virtualization slows things down. So a very crucial area is helping that. And I noticed you had some talks about the Uber cloud. Also a company like Cycle Computing we think is an example of not just a successful company, but a whole new segment that's potentially going to be out there. And that's helping people use clouds. We've done a number of studies on small, medium enterprises as far as what the best practices, partnering, and I mentioned some of the funding things that are taking place. If any of you want a copy of these studies, just shoot me an email. I'd be glad to send you the entire study there. And this is really what has worked, what has been successful, and what hasn't been successful. That's what these studies are on. So many of the success stories are out there. A lot of cases for the new startups too is the HPC centers, whether it's academia or the government labs, are very interested in helping new startups. In fact, if you look at Europe in particular, they have a direct mission to do so. The US is trying to get those missions in there where part of the academia sites and the large national labs actually have to help companies in their local area. So then I'd like to switch gears completely as far as our first guess is some hot growth areas. I'm sure we've missed some of the other key ones. But first of all, why is this whole market still growing? Why is there so much money? The governments around the world are showing a renewed interest in HPC. Shaheen, I think you've also mentioned the issue of, HPC kind of became a dirty word, and supercomputing, the investment community doesn't get excited. Walk in the door and say, I've got a new HPC company, or walk in the door, I've got a new game. I mean, the reception you get is just entirely different. At the government level, that's swinging back. Because governments, with the recession and everything else, what they recognize are a couple fundamental things. Their countries need to be innovative, or the innovative companies are going to put them out of business. And so how do you become more innovative? You only have a fixed set of scientists and engineers. How do you make them more productive? So they can be more innovative on a national scale, and HPC is that tool. So tremendous investments taking place there. The second one is there's some critical issues in the world that need to be solved. Now, global warming is one we've always had up here, based on politics and what country you're in, that can be hot or cold, so sorry, so to speak. But alternative energy, tremendous money going there. Safe nuclear energy is also being heavily invested in. But all these areas right here, again, there's many different point solutions that are needed, and that's where startups can come in and help out. And then there's all kinds of new applications, whether high-performance data analysis, deep learning, but also real-time analysis is a really major issue for a lot of these organizations. The big issue about big data is, first of all, if you're going to do something with big data, one, you have to get the information somewhere. Secondly, you have to invest from an organizational viewpoint to store and keep all that data, which is very substantial and costly. And third, then you have to make use of it. And the whole hope here is the first step is you make use for it. The particular applications like fraud detection, some basic ones. But eventually you want the machine to get smart enough to actually make decisions. So that's why there's so many different places where investments are being made there. And so some of the major customer pain points, I've mentioned a couple of times about the software issues. But first of all, management software is needed. These machines are hard to manage, they're hard to configure, they're hard to change over time. And as I mentioned, the whole lower half of the market has basically gotten rid of the large part of their IT staffs. So they really want people that can come in and help solve that problem. I've already covered the parallel software and the applications. When I mention redesign, I'm not talking about taking their application and changing it a little bit to run on a new piece of hardware. What I'm saying is the core science in the applications, and we've done a number of studies on these, actually needs to change. Because you can't think of a serial process, like when you're doing an airflow, or if a design of a structure, you need to think of it in a parallel fashion, which actually means putting new physics and new research into the applications themselves. And these are each, individually, we've seen many of them which are $1 million plays. What I mean, for a startup to come into a company and help redesign one small application, they'll pay on the order of $1 million a year. Is not unusual. So that's a fairly sizable business that can be. The other part on how to use and manage clusters, everything about them are very difficult, from planning. Power, cooling is a massive issue right now around the world. So these are some areas that are pain points. On the software one, though, I want to drill down a little bit more, and I hinted on this earlier. Ease of use is the biggest issue. These machines are hard to use right now. As they're getting larger, they're harder, and like I say, each organization is downsizing the computer science people. So anything you can do to help in that regard would be tremendous. Adding these new technologies into existing applications is another key area. One thing we do track is within each of the buyers or user organizations, where are they spending their money? Are their budgets going to go more for hardware next year? Are they going to go to services? Are they going to change and revamp things? And what we've seen in the last 3 years, the whole thing around big data and IoT, if I just take those two, have been the biggest budget swings we've seen since we started tracking 15 years ago, these budgets. So the amount of money that's going in those directions. And again, I mentioned exascale if you're doing something with HPC. If you're making a new business proposal in HPC, putting the word big data somewhere in IoT also would be very helpful in that. And meaning that you're actually delivering something in that area. The individual services I think I covered quite a bit. But the last one there I wanted to mention, the using clouds for HPC really requires some changes also. And we think this is probably the #1 area where startups can walk in the market, fairly quickly make some successes. And the bootstrapping part of it, this is an area where you can get some money fairly quickly because you can help one or two companies solve the problem as you invest in a more general solution that you can apply to many other people. And for example, what Cycle Computing does is they'll come into like a pharmaceutical company and say, hey, you want to run billions and billions of iterations on this new drug. And they say, but you'd like to run in the cloud, but you have no idea how to set it up in the cloud or anything. What we'll do is we'll take your job, we'll invisibly run it on the cloud for you and give you the results back. Wonderful thing. People love that. That's the absolute ease of use, right? Step further, Cycle goes. And here's Amazon's published price list. We'll give you even 10% off that. And then Cycle will go in and they'll go on the open market to buy the Amazon processors at a fraction of that price. So not only do they make money on the ease of use side, they make massive money on the fact that they get to buy the asset, meaning the Cycles, on the cloud for much less than they're selling to the end client. Everybody's happy in that equation. So that's why I'm saying, or our view is that Cycle really has actually opened a whole new market area. On the storage side, storage is actually the fastest growing of all the subsegments we have here as far as hardware and everything. I mentioned with big data, the first step is you have to find the data and acquire it. The second one is you have to store it somewhere. So that's part of the reason storage is growing heavily. But the other problem with big data is once you have this massive data, you have to move it around. You have to get into the computer, you have to do some kind of processing, you have to send it back out to someone. All of that takes a lot of time, cycles, and everything else. So that optimization of that process, we think for the next 10 years will just be tremendous opportunities. And again, that's where we're seeing a lot of buyers are telling us that's where they want somebody to come to them with solutions on that part. The big players are starting to turn their attention to this market. So we always warn startups, when the big guys start coming in, you have to be a little bit more nimble in that regard. The other part of it is the whole interconnect market is going through a transition. And again, whenever there's a transition, having solutions that help through that transition. And the last one right there, we're seeing some real boosts in storage budgets right now. One of my favorite ones that we've been working with, and they said we could mention it, is Procter & Gamble. And right now, Procter & Gamble, every time they make something, they put an RFID tag on it. Every diaper that's made has a separate RFID tag that goes through the entire system all the way to the end part of the market. So in theory, you could actually do some tremendous big data on that. Because you have every information every step of the way, how hot the cloth was at this stage, how fast the machines were moving through at this stage and everything. But their management won't justify the cost of the storage system. So what do? Once that diaper goes into the truck, the data is dumped completely. And so they're trying to figure that out as saying, gee, we could use that information, we could do some interesting things with it, but we can't justify even the cost of the disk drives. So, those are examples where if you walk in and say, hey, from a marketing perspective, you could do this. Hey, from this, we'll step in. And in Procter & Gamble's case, one could actually step in and say, we'll store all this stuff for you and we'll give you the results. You pay us $1 million a year now. And that would be something they probably sign up to in a heartbeat. And again, it's also a CapEx, OpEx issue. If you can take those both totally off their plate, then that's a good proposition. The storage access time, as I mentioned, moving the data around everywhere also has become the #2 pain point. I mentioned software is the #1 data point. The problem with moving storage and data around too much, it takes electricity, power, and cooling to move it around. These machines typically now are running 5 to 10 megawatts. Some of them are much higher, 20, 30 megawatts. But to put that in perspective, that costs about $1 million a year per megawatt. So if you have one of these supercomputers that's at 10 megawatts, your power bill is about $10 million a year just for electricity. Now, the hidden cost is the actual equipment to deliver that power. The transformers and everything else are about 60% more. So it's about $1.6 million per megawatt is what they're paying out the door every year. So this is a case where anytime you can reduce that movement of data, you save money, and you can actually show these folks how much money they're saving. They actually already have the models and the way to calculate it. So it's something where if you can say, hey, I can give you a 5% reduction in the movement of data across your data center, that's going to save you X million a year. It's an equation they already understand how to calculate and believe. Another thing we always say is chase the large budgets. I've mentioned a couple times, the government bodies are spending a lot of money here, they're spending a lot of money there. We always view one approach is, hey, just look where a lot of money is being spent and then try to have a business that goes after part of that funding. Software, as I covered, new hardware solutions. Some talk was earlier about DOE and some of the individual investments they're making right now. There's a whole new exascale program that's launched, and they've initially, I think it was, 42 application areas they funded. Another 17 will be announced soon. They plan to announce on the order of 15 to 30 investments every 6 months. And a lot of them are going to smaller startups. And that's why I say chase the money, find out what they're interested in. And I'll tell you what, we're actually doing, as I mentioned, multiple grants with Department of Energy. I'll tell you what our selling approach is on this. We walk into them and say, what are your biggest problems that are of the nature we can solve? We'll have about 4 face-to-face visits before we even think of what kind of proposal to write for a grant. And then we write a grant based on those 4, based on those 4 meetings, we write a grant up. And our grants are sole sourced. There's no competition. And so by doing it that way, you've already sold your customer. You've already sold the customer because you're doing what they've told you they want the most. And so it's a very good way to get some upfront funding for the different things. And like I say, it's a kind of a twist on co-design, because once you work through that portion of it. And as I mentioned earlier, I have a couple of slides here then on big data combined with HPC. Plus adding IoT and these other pieces. So the way we split up the big data market is we really have the modeling and simulation is more the traditional folks that are doing it, and the advanced analytics are the new companies. And here it's just been amazing to us. The person on my team, Steve Conway, who leads this, we asked him to get 200 examples of real buyers before we even talk about definitions or everything. It took him 4 months. And it was just a shock to us that within 4 months he had 200 new buyers in that advanced analytics. And that's what we then used to create all our numbers and kind of definitions. Since then, the number's grown to over 700 different sites. The amazing part that's happening here is we always call in HPC, there's certain magic points that can happen. And Shaheen, I know you remember these very well. If you can take your whole job and fit it in main memory, all at once, everything runs 1,000 times faster. And besides that, you do something different, right? One of my favorites is the US Post Office. All the mail going through the whole postal system was randomly checked. And like, for example, if you go to mail a letter now, one thing they'll say is, do you want the full routing tracking number? They do that on every piece of mail now. Well, what really did they change? And they did this for fraud detection, by the way. They bought the largest SGI box, as far as S&P, and filled it with flash memory too. So maxed out the main memory, maxed out the SSDs you put in it, and they could put the whole model inside the box. Changed the nature of the post office business entirely. They check every piece of mail that goes through the system. The moment the piece of mail hits in, it's already been optimized routing and everything. Where's the fraud detection? If you've ever seen commercial business mail, people bring in buckets of envelopes and they say, I've got 200 envelopes in this bucket, and so they pay for 200. Well, in reality, there were 2,000 frequently. And a lot of time people didn't put enough postage on. Random sampling meant a lot got through. So the fraud detection part of it is saving them on the order of $1 million a day right now. So $1 million a day savings on just the inappropriate mail size, and the system was $13 million that it cost to put in. They have about 3 startup companies that are working with them right now to help optimize it to the next generation. But it's just amazing things. Worldwide for the US Post Office, it's all done on one computer too. Instead of distributed clusters and everything. Again, they went out there and said, hey, let's fit everything into main memory. But that's why when a startup comes in and says, hey, I can take you to the next level, you can actually change the nature that the business happens. And that's where real money can flow. Here's just some of the various categories we think. I mentioned fraud a lot because the fraud one is where you just have these massive success stories. The other big one we have is with PayPal. PayPal did a similar thing. They bought a similar SGI box. They paid on the order of 10 to 14 million. And if you're familiar with PayPal, when you make a credit card charge, they check your name, your address, the card number, security code. So then the system said, yes, we're going to approve it. It went into this SGI box, and I'll just for a moment say black box magic, and then sometimes it said no. It said no, $710 million in the first year. So they saved on, again, about a $10 to $15 million investment, that much in just the first year. What PayPal, because of all these successes, is now actually monitoring all criminal behavior around the world related to credit cards. And they have an entire data structure. They know every scam. If somebody goes into a restaurant in London and 3 people tweet, because they're actually monitoring social media too, and say, hey, something happened with my credit cards, that goes into that black box model magic. So it's just phenomenal what they're doing. Again, when you have returns like that, it's very easy to justify new investments on this part. Here's our forecast for this HPDA market. As I mentioned, it does have one of the highest growth rates we've seen in a long time, on the order of 26% growth a year for these new applications. We're actually redoing our forecast right now, and they're going to be actually somewhat higher because we missed a couple examples on this one. Here's a percent within the HPC area as far as where they're currently using big data and planning to in the future and so on. And you can see the percent of the systems currently doing it is about a third of the market. The percent that expect to in the next 6 to 18 months is another third. Yeah, so, okay. So we'll be at about 2/3 of the market will actually be doing HPDA. And then I've got a couple other slides here on the HPDA side of it, like where workloads are run. Here's one is our kind of predictions of just how we lay out the market. And for some reason, the PowerPoints didn't work here. I'll make sure you have a PDF version that shows what each of these. But these are 10 segments that could be invested in, based on the nature. The other part I want to talk about is the return on investment. I've mentioned a few examples. We're announcing tomorrow morning the results of one of our research grants. This is tracking when somebody makes an investment in HPC, and then it's economic modeling, so we ignore all the stuff in between, like factories, sales forces, and then what do you get out of it in revenues, profits, and so on. And right now, across our sample of 148 on the financial side, the average dollar in HPC is generating $551 million in revenue and $52 million in profit across these examples. The one thing we're making available to everyone is that whole set of 148. Again, since it's a DOE grant, the thing we have to do is we have to make the data available to everyone so everyone can see this whole data set. So it's a whole lot of success stories. And what we mentioned for startups, when you go for that venture capital funding and somebody says, well, what are the examples of people make money, what segment? You can sort this by industry, country. In this case, I'm showing the industry one. All different ways you can sort this data to put that kind of business plan together. And it's really a planning tool that we try to put together. The other part is job creation. You can imagine governments are very interested in this, and this is why we have 6 governments around the world funding this whole program. The job creation part we're just getting put together. In the sample, it's about just shy of 6,000 jobs. But we're walking through how much in HPC invested generates a job, because we're helping the governments make their economic decisions there. And there's by industry. And in summary, because I'm just about out of time, I know. So we do expect it to be a high growth thing. Vendor share positions are going to shift greatly. And they shifted greatly in 2015 and going forward. The reason we bring this up is whenever vendors are changing and who's the leaders, there's room for startups. There's a lot of things. The other part we always say is for a startup, in our view, is what's your exit strategy? Where are you going to make the truly big pot of gold? Right now, these vendor shakeup and competition is so hot that if you do have a good product in this area, there's multiple vendors that will buy out your company. And there's vendors on the market. HPE and Dell are right now in total competition for dominance. And they're buying up probably on the order of 2 or 3 small companies a month right now. Right now, Lenovo in China has become a giant vendor. Inspur and the other Chinese vendors now either have to acquire and get as big, or they're going to be laid to waste. And this is from the Chinese pressure side. So the other Chinese vendors are trying to make investments all over. I say we get a request about once a week from those vendors to evaluate a company for them. So tremendous exit strategies here right now too. And with that, it might be a time for a question or two, or not?
Yeah, absolutely. Yeah.
Sure. Yeah, hopefully I didn't go over too much.
That's okay. So questions. So fan of a question. I have. Somebody else does.
Yeah, I do too.
You ask us.
Sure.
All right. So I'll go with the AI thing because it seems like all HPC companies are now rebranding themselves as AI companies. What's your perspective on that? Is that going to be completely the future of HPC, or?
Right. So first of all, I should say our definition of AI is a little different than what a couple companies are trying to say right now. And you're right, a lot of companies are moving that direction. We view that you have structured machine learning, unstructured machine learning, then you actually do let the machine do some decisions based on fixed rules, and then you actually get to AI. And most companies are calling that whole realm AI, which I'm just saying definitionally we're a little different there. It's one of those hot topics where they tested out deep learning and machine learning, and a lot of people didn't understand that very well. But AI, that's been around long enough that conceptually everyone gets it. So we're seeing a lot of people using that branding. We do not believe, just to let you know, that that little realm is going to be all of HPC at all. We think that naturally, more machine learning is going to be incorporated into things, but by itself, it's a segment. It's going to be a healthy segment. Don't get me wrong at all, and it's growing very fast, but it's not a take over the world type segment. By the way, the intelligence community is definitely on the AI side, and they're probably the ones investing the most right now on the AI side.
Do you make a distinction between the actual training and learning aspect of it, and like the inference and the actual use of the models?
Yes. So for example, for our HPC numbers, if you ever see any of ours that we show on that, we really only have the model development, the training side of it. The actual implementation we view as more commercial processing. And it's not a perfect definition, but we usually, that's what we're seeing to date so far.
Yeah, it sort of follows on from that question. How do you see the growth and the spend, between traditional CPU and GPU?
Right, so we track both of those. Right now, the market is about 85 to 90% x86. And we are tracking the GPU spend and the GPU counts along with that. The GPU counts are growing dramatically right now, but again, from a very small number. And so we're tracking very carefully. We're also trying to figure out, by the way, everything we do, we have to have 5-year forecasts. So whenever I say here's a trend or a market segment, that's part of our charter. We're trying to figure out for GPUs is how many GPUs are going to be attached per processor. So if you take a 2-processor node, will be 2 GPUs, 1 GPU, or 8 GPUs, or something larger than that. And that's the model we're just putting together right now. But the GPU growth is fairly high, but it only works in a limited application area so far. The bulk of the applications can't take advantage of GPUs.
A completely different
Sure.
question. One of the concerns you showed was obviously power and cooling, and we all know it's getting out of control. I looked at the exhibitors, and at least half a dozen vendors there who are looking at various forms of immersive cooling as a way to solve that problem. Any thoughts, insights on that?
Right, so we've been, I used to work for Cray, so immersive cooling is something I love and, exciting area there. Also, I live in Minnesota, and that's where most of the liquid's made by 3M.
Well, that's still there.
Yeah, absolutely, and new versions that aren't harmful to the world or poisonous when you heat them up too much. But the immersion cooling actually does have a good fit. The problem is it adds a lot to the cost. And one part about HPC that totally changed in the last 15 years is cluster computing using x86, and that became good enough computing. In other words, it wasn't as fast as vectors, it wasn't as fast as custom stuff, but it was about 30 times cheaper. And the problem with all the different new things you add to the system, almost no one has a stomach for 15% extra cost. Because 15% more cost means you have 15% fewer processors, which means maybe you get much lower in the top 500 list, which is still a big deal. But the immersion cooling and all the liquid cooling technologies, we think there's going to be a strong place for that, in particular in data centers that have run out of space in the room. And when I say space, I mean space to put the physical room, but also space to get the cooling and heat in and out. And that's where we're seeing the first home runs there. I think the immersion cooling from 3M, their first beta site was at Bitcoin in Hong Kong, because they had to put it upstairs, and there was no way to add cooling in that old building.
Thanks.
Go ahead.
When do you think we'll see an X-scale machine?
I think the first, we'll be showing the charts tomorrow morning, but we think the first X-scale machine will show up in, let me make sure I get this right. So the peak one will be in China. The contest is for which vendors are going to get the funding happens in early 2018. There's 3 competitors. We think it's going to go down to 2, but they're publicly saying going down to 1. And that's going to be for going live at the end of 2020. Because it takes them 18 months from the time they get that funding. So that's going to be the first peak one that we're aware of. The U.S. government, you're probably familiar with, is playing for more of a robust, usable exascale. But there's a small group in the U.S. government that's saying politically we need to do a peak machine also. So there's a potential that something new could come up. But at the moment, that's the first we have. Japan will probably be fairly late because the Recon system is going to be based on ARM processors with vectors by Fujitsu, and it's not fully funded by the government yet. And then Europe has 2 major programs they're funding, and they're expecting more in the 2022 range.
So I read some of your reports, really good stuff, but it costs a lot of money. And if I'm just exploring stuff that doesn't really make sense monetarily for me to pay X amount of thousands to get a report, is there, I guess, are there any particular discounts that you guys offer, or alternatively different sources of research information or tips for finding?
Perfect question. So let me explain our business model a little bit to you. I always say this, everyone who ever says, I went to your website and saw the price of your report, nobody should ever buy an IDC report from the website. And our business model is not to sell them through the website. Our real business model is people subscribe to us on a yearly basis. And so on a yearly basis, you get like 40, 50 reports for about $25,000. I'm not saying that's your solution, but I'm saying that's for all of our clients. For startups, companies, and clients who have never used our services, when you need a specific question, the best way is to do inquiry with us. And under the umbrella of prospecting and sales calls, we'll actually send you a bunch of tables. And so for most startups that we've ever dealt with, you don't need any of our reports, because our reports are for like an HP or like an Intel. You may need 2 or 3 tables, or how big is this market if you cut and slice and dice it this way. And the best way is to do a phone call with us. We put under a prospecting umbrella. It costs you nothing. And that's how we try to help the startup community. Because we don't expect a startup company would spend the amount of money we charge for market research. I mean, because just our pricing and our structure isn't designed for that. And that's why we do it as a free thing.
I'll start spamming those emails.
What was that?
I'll start spamming those emails.
So you can send it to any one of these people on the team, and just the best way to say is, I've got a couple questions in this realm, I want to set up a conference call. And then the reason we do a conference call is we only publish about 1% of our data right now. And so generally in the conference call is, oh, are you interested in worldwide market or US only? Are you interested in things at this price, this, you know, we're just trying to figure out the box that you're interested in, and then we do a run of the database and give you a custom table, as opposed to just sending you a table out of a report. And that's why the phone call is so important, is we have to figure out what you really need.
Awesome, thank you.
Sure. Sure.
Well, actually, you should eat.
Okay, right.
Because you're on next anyway. So.
Okay, I'll take it otherwise. What is your perspective on Hadoop?
Right, so Hadoop is very popular across the board. For the big HPDA part we're talking about, and let me separate, you've got big data that spans the whole area, right? And internally we always debate, you know, what's HPC versus commercial? And it turns out for big data, commercial stuff's done on 1 or 2 nodes. And HPC stuff's done on many nodes, and there's almost very little between that. So Hadoop we view right now is basically like a compiler. For most of the HPDA stuff, people will use Hadoop. It's a good growing area, but by itself it is not sufficient whatsoever. And so, but you use it as a starting point in the analysis. All the things like Spark, graph analytics, and all that are usually what's layered on, and we actually have a whole report that lists all the different softwares, how frequent they're used, and so on.
Excellent.
Okay.
Well, thanks.
Great, sure.
Really good.
Good seeing you guys.